Welcome to the video lesson on drives and greatest integer functions. So consider this greatest integer function. If you were asked to complete a drives analysis of it, the first thing you should probably do is to sketch it out. And a sketch is different than a graph, although what I'm going to show you is an actual graph because I just created one in Desmos. But what you would do is probably draw a rough version of this, like to start at 3 and 1 with a filled in dot, figure out that the step length is 1/4, 1 over b, and that it opens to the right. Figure out that the height or vertical spacing between steps is 1/2, and that because a times b is negative, the steps decrease. So more or less that it's going kind of like that, and approximately what the step length is. And based on that, we can already start to solve or answer some of the drives questions. Like, I know that these steps are going to continue all the way left and all the way right forever, and that means that the domain is negative infinity to infinity, which you can also write as all real numbers. And that's going to be true for any greatest integer function. The range, on the other hand, is not going to be negative infinity to infinity, because if you look at this type of function, it has a y value here, and then it skips to the next y value here, and it does not take any of the y values in between. So the way we indicate that is rather than using square or interval brackets, we use squiggly brackets, and we would list the y values that are part of the function. But here there are still infinitely many different y values. So the way I would write the range here is like this. And what that means is that I start at 1, a y value of 1, and that I jump by increments of 1/2. This n, because I'm specifying that n is an integer, means that I'm adding or subtracting, because z includes negative numbers, 0.5s or halves. And I would keep adding more and more 0.5s. I can add 2 of them, or 3 of them, or 4 of them, or 5 of them. And I can subtract some too. So I end up moving up and down by increments of 1/2. In general, what I would write is I would always start with k, because I know that k is one of the y values that's part of the function. And then I would add or subtract, it doesn't matter, the absolute value of a times n, where n is an integer. And that's just one possible way I could write it, because I could skip to any one of these steps and start from there and add or subtract a times n. But k is an easy one to start with because I know that this is always going to be one of the y values that is part of the function, so that's always a good place to start. So that's domain and range. As for the initial value and the zeros, the intercepts, the I part of drives, initial value in this function, just like in any function, is when you make x equal to 0. So if you'd like to pause the video and give that a try on your own, I encourage you to do that, but I'll skip through the calculations and show that when I make x equal to 0 and simplify, what you end up getting is one specific y value, in this case 7, and if you were to continue this all the way up to the axis, you would find that that's the value on the axis, or where the x is 0. And similarly, the zeros are where y is equal to 0. And there is a separate video on how to solve an equation like that. If you want to watch that one, you can, and if you want to pause and try it on your own, you can. But the short version is that you would isolate these brackets on their own. And when you get to that point, there are two methods. One of them is to, at this point, take a look at one of the steps. Because b is positive and a value of 4 means that each step itself has a length of 1/4. And algebraically, I can now ignore these brackets and solve just for x, and know that the x that I find is this x value here. It's the filled in dot. It's always the filled in dot. So because my step moves to the right and is a length of 1/4, it means that the other half of this is 15 over 4, or in decimals that this is 3.5 and this is 3.75. And what I found was this, the filled in dot on the axis, the filled in dot of the zeros step. And so I can write that answer as the interval from 7 over 2 to 15 over 4, or in decimals 3.5 to 3.75. Or alternatively, from this point, what I could have done was to set this up as an inequality and divide both sides by 4 and add 3 to both sides, and I would end up getting the same answer anyway. So those are my zeros here. As for increasing and decreasing, the variation part of drives, we would say that a greatest integer function is either always increasing or never increasing. And this one, by virtue of the steps decreasing from left to right, means that the increasing component here is nothing, none, and the decreasing component is all real numbers, or negative infinity to infinity. And so every function will have one answer like this and one answer like this. And whether it's increasing or decreasing that exists depends on whether the steps are actually increasing or decreasing from left to right. And as for the positive and negative, what we're going to need is that information about where the zeros are. Remember that our zeros happened here, where this filled in dot was at 7 over 2 or 3.5, and this open circle was at 15 over 4 or 3.75. So positive includes where the axis, or where the function touches the axis. It includes the zeros. So if you want to pause and give this a try on your own, you can, but I'll take you through the answer now. This function is positive starting all the way left, so from negative infinity, and because it includes what's on the axis and because we read it from left to right, I go all the way to the rightmost part of this step, and my answer will be from negative infinity up until 15 over 4, excluded because the function is excluded at that very point. If I had included it, it would mean that I'm including this point, but at that point the function is negative. And strictly positive is different than positive in that I only include parts of the function that are above the axis. I don't include what is on the x-axis. So that means I'm going to stop at this step, which ends at 7 over 2, excluded. Because reading from left to right, there is an open circle there. And negative has the same idea. If you want to pause and give it a try, you can. But as I'm reading from left to right, this function starts being negative at this, the leftmost part of this step, because I read it from left to right. That would be from 7 over 2 to infinity. And strictly negative is only below the axis. That starts at 15 over 4 and continues till positive infinity. So that goes through all of the important criteria or categories of drives. I hope you found this video helpful.